is Unpeeled. And today we're going to be talking about Alquist. So Alquist is a concrete or construction 3D printing company, and they've done something I think is very, very bright indeed. They have started with a local community college, they started an Introduction to 3D Concrete Printing course. Self-paced course, 30-hour certificate. It's 4 units, and it costs $250, which I think is great. The course itself will look at the robotics of 3D printing, the actual motion control, motion stages, things like that, the material science behind 3D printing concrete, different cements and other mixtures used, the printing characteristics, how to make it adhere, how to strength test the material, the pumps, which are actually the really important thing because they pump the cement through into the motion stage, just overall design. I think this is an absolutely fantastic idea. First off, there is no really globally available 3D printing class in 3D construction printing, which is like the leading one or anything like that. All the other efforts that have been out there are kind of sporadic. They're doing this with a local community college in Greeley, Colorado. And hey, this might feel, this might end up becoming the definitive 3D printing class. And then Alquist will be able to show, its thought leadership. We'll be able to educate a new generation of people and new construction people, designers, architects. And hey, maybe they'll, definitely they'll be branded kind of Alquist kiddies, if you will, be learning all about the Alquist equipment and stuff like this. But they'll also be very predisposed to like these people. So I think it's really brilliant. What makes this extra smart is that Alquist has recently relocated to Greeley, Colorado. So they're doing it with a local college to show the local, their kind of go local kind of idea, and then showing that they're a really important part of that local community, and they have a role to play. So I think this is super smart. I don't understand why nobody else does this. You could do this in a lot of different disciplines, and also, for Alquist itself, they may be able to find some local employees that take this class that could be especially talented. They can use this to find new people. So I think it's absolutely fantastic, really fantastic. I think more companies should do this. In our market, we all have problems socializing the technology. We all have problems teaching people. We all have problems finding the right people. So I think this is an absolutely fantastic move by Alquist here. 3D Systems is releasing a EXT 800 Titan Pellet printer. That's an 800 by 600 by 800 millimeter pellet printer. It's more compact than some of the systems they had before, although it has a really large build volume. We class this as a 3D print company. Class this as a medium format system, around and up to a meter. Anything like 50 centimeters and below is just regular format 3D printing. This is medium format, and large format is everything bigger than a meter. Typically in the medium format, in the regular format space, we make human-sized objects, and we make things that are meant to be touched and felt and used in and around humans. Medium format 3D printing, we make larger than human objects that are meant, that are molds for human-sized objects, for example, or we make things that are larger than people, or kind of larger than people, to be used by people. And then large format, we make things that contain people, like boats and planes, and tooling to make boats and planes and things like that. That's kind of how we differentiate them. If you look at these 3 markets, your desktop or your industrial printers have to be very, very precise, have to work really well, high reliability, repeatability, very good layer adhesion, because the parts you need are either going to be very functional, or they're going to be used up close to people. Medium format, what you really want is a system that can lay down an awful lot, high flow nozzle, lay down a lot of material in a short amount of time, and build a big object kind of very, very quickly. Because if you would just scale your Prusa printer to print like a thing the size of a couch, it's going to take weeks, and that's not really going to work. So we're going to sacrifice a little of that accuracy, a little of that in-layer adhesion, that optical quality, for cheap and really, really big objects that are made fast. And medium format, it's a question of making something that's several meters in size. So, that they have big problems with warp, and they have big problems with getting that object to come out in and of itself. Typically, a lot of medium format objects are finished. So they're put into a mill. Some of these machines will have a milling head inside of it. And then a lot of large format parts are also finished as well, especially if they're molds or tooling and stuff like this. This market is growing really quickly. It's an unserved market segment. There's lots and lots of players in them, and a lot of them kind of suck. So it's good to kind of release products into this. And I think that 3D Systems, which traditionally, of course, the VAT stereolithography or stereolithography type processes, that polymerization type of processes, for them to buy Titan and have a credible offering in this kind of space is very, very smart. It's also tooling adjacent. A lot of the people doing this are doing this for aerospace tooling, so that makes it really smart, overlapping customers they can sell to. And indeed, the company says that instead of tooling, they're thinking of fixtures, end-use parts, including aerospace and defense and all the normal ones you thought of. And this is a quickly expanding segment. We can see this because there is another, on the same day pretty much, there's another company that is releasing a similar system. Now, the 3D Systems system is a pellet-based system, which is cheap. Pellets are cheaper because you don't have to turn them into filament, and but we sacrifice a little bit of quality. We think that usually filament will print better and have a better surface finish. So typically speaking, if it's a mold, you'll probably be better off in the end making it with filament because it's faster, because you don't have to mill it down afterwards. But if it's an optical part, well, it depend on the quality you can get and the time and the cost, which one of these technologies is better. So everybody's kind of figuring out what to do. And Big Rep, we did a big acquisition for them that really expanded and matured their printers a lot. Now has another system. It's a 1,000 millimeter by 500 by 500 millimeter, and it's called, I think it's either the 7.0 or the VIIO 250. I'm not entirely sure. I don't know why it's called the 250 either. It's a bit confusing, but it's got an auto filament loading feature, dual extruders, whereas the 3D Systems system has one extruder, and it's capable of extruding materials up to 350 C, which gets a lot of engineering materials that you're really kind of very interested in. A lot of people here would do PPGF, so polypropylene, glass fiber filled polypropylene, stuff like this. Or because that's also familiar with the automotive industry, works really well for some tough, strong, dimensionally accurate parts in this kind of shapes and sizes that they want. A lot of people also want to use things like PAGF, so polyamide GF type of thing, which is good performance typically as well. Well, it's a bit tricky to print, and a lot of people use material like PEC and PI and in this area as well, where the polyether ketone is very, very high performance material. And PI, also called ULTEM, is also a high performance material used a lot in aerospace. So those are the type of things that this thing will be used for. It can be used with a dry box, and it's a competitor. So it's good for this segment to show that more or less at the same time, two printers that are angling for the same kind of application, tooling, aerospace tooling, and defense, and jigs and fixtures are being relaunched in the same segment at the same time. And it's a huge unexplored area, and I think even the large format stuff is even crazier because the parts are so big, it's very difficult to do them. So very few people can actually make multimeter parts. But just think about how much money you can save by not having to mill a giant wood mold and have a bunch of guys climb all over it, make a carbon fiber or fiberglass kind of version of that, and instead just print that thing directly. If they could do that correctly, they'll save the boat industry alone like so much money and so much time. And so much inventory and so much space is completely crazy. So the opportunities here are very little understood, but we're very, very excited about a lot of them. Anyway, so my name is Joris Peels. This was 3D Printing News Unpeeled.